Out and ready to go. All right, so we're looking at problem 8 on the 2022 Math Counts chapter competition. This is a target question, so you have a calculator, you have your calculator out, and we have a really cool little probability problem. Now, you'll remember from previous work that sometimes when we have a more complicated probability problem, it's easier to find all of the ways it won't happen as opposed to finding all of the ways it could happen. All right, so that's a strategy that we worked on earlier. So here we go. Now if I write it, what should you be doing? That's exactly correct. All right, so a machine randomly generates one of 9 numbers, 1 through 9, with equal likelihood. Now does this machine generate a 4-digit number, or does it generate 4 separate numbers? These are 4 separate numbers, which means, are we able to repeat the same number? Yes. Yes, we can repeat the same number. And so what is the probability that when SUNY uses the machine to generate 4 numbers, that their product is divisible by 14? Now, what does product mean? Okay, so essentially what's happening is we have 4 numbers, 1 number, 2 number, 3 numbers, 4 numbers. And what are we going to do with the 4 numbers? Nope, we're not dividing by 4. We're multiplying these 4 numbers. And the question is, what are the chances that I'll get a number that's divisible by, actually I'll use this, that's divisible by 14. So that's what we're looking for in this case. So, all right, so how many different numbers do I have that can go right here? 9, okay. And so the question that we have is not what are the odds that we would, well, wait a second, actually, before we even get to that, 14, that's kind of an interesting number. What has to be true about one of these numbers here for us to be able to divide the product by 14? What has to be true? I see some hands. Yes, Madison? Morrison, oh my God. I'm saving that for posterity, so my shame will live forever, Morrison. All right. One of the numbers has to be 7. So the first thing we should look for are, what are the odds that we don't get a 7? 8 out of 9. Okay. So the odds that we don't get a 7 are pretty good. They're 8 out of 9. So what are the odds that we don't get a 7 on the next one? And the next one. And the next one. So the odds of not getting a 7, so no 7, is going to be 8/9. And how many times are we multiplying 8/9 together? 4. All right. So y'all with the calculator, would you please go ahead and figure out what is 8/9 to the 4th power, please? And while you do that, I'm going to pull out a calculator. I don't want that. Thank you very much. This video is already a disaster. All right, so 9 times 9. So what is 9 to the 4th?
6,560.
What is 8 to the 4th?
4,096. Yeah.
So the odds that we will not get a 7 are pretty good. They are 4,096 out of 6,561. Now, I know that 8 and 9 do not share any factors, so that means the way to say that is these two numbers are relatively prime. They're prime to each other, which means there's no way I can reduce this fraction, which is nice. And now, what must be true about one of these numbers other than one of them has to be 7? what else has to be true for us to be able to divide this whole thing by 14? Brooks. One of them has to be even, because an even number has a factor of 2. When we take that factor of 2 and multiply it by a 7, we'll get 14, so we'll be able to divide by 14. So in my group of numbers here, how many numbers are even? 2, 4, 6, 8, right? So if there are 4 evens out of 9 numbers, how many are not even? 5. Okay. So what are my odds that this number right here will not be even? 5/9. All right. So what am I going to do with 5/9 to figure out how many variations? To the what power? Not third power. How many numbers are we multiplying together? So, okay. So this is no evens. And what is 5/9 to the 4th power? I'm pretty sure I'm going to get the same denominator. That would be really helpful. So what is 5 times 5 times 5 times 5? Oh my gosh. And I know it's 625 because 5 times 5 is 25. That's 2 of the 5s. I have 2 more 5s. 5 times 5 is 25. And I know 25 times 25 is 625. So I know I'm right. Or I know you're right, I should say. All right. Now, here's the problem. Excuse me. We have a situation here. We have no 7s, and we have no evens. Now, is it possible that we're doing some double counting here? Are there some numbers that are not 7s and not even no evens that overlap? Oh. So what numbers are we including in this twice? All the odd numbers that are not. So how many numbers are not 7? 4. Okay. So we are double counting all of the odds that are not 7. So, okay. So how many odds? So what are the odds? Or what are the chances that we'll get an odd that's not 7? Okay. So we have 4/9. And how many different numbers are we multiplying together? 4. So what are the odds that we get an odd that is not 7?
256.
So here's the thing. These are odds that are not 7. Yep, ops. Yep, there you go. And so we are counting these twice. So that means we need to take this amount out of this one right here, don't we? Because this is being counted in this right here. They're also being counted right here. Is that correct? Okay. So if I take the 256 out of the 625, how many actual how many? 369. Can I get someone to confirm that?
Yes.
All right. So all told, really that's 369 out of 6. All right. So how many total options will not be divisible? Sorry, my fault. How many total options will not be divisible by 14? Well, these are not divisible by 14. This isn't divisible by 14, so how many options aren't divisible by 14? Those two combined. Combining is what operation? Adding. Okay, can you add those for me, please? Now, is that the correct answer? Why not? Though this is how many that's wrong, I need to know how many are right. Okay, so how many total options are there? Okay, so we have 6, 5, 6, 1 over 6, 5, 6, 1. Well, this is just a fancy way of saying 1, and we are sure to get one of these numbers, right? We have a 100% chance of getting one of these numbers. We're going to subtract these, and what will we get?
2,096.
Out of. And remember, it's asking to find the probability, and it's telling us to give the answer as a common fraction. So we have to do 2096 over 6561. And that is the correct answer. Yes, sir? You could definitely do it in 3 minutes. Now, granted, this video is a lot longer than 3 minutes. Why? Well, because we explained every step. Now, as a 6th grader, the odds of getting this are? No, it's not 0. I definitely have met some that can. However, the odds are not very good. And to be honest with you, in Math Counts, I've only seen on 2 occasions people getting a perfect score. So there are going to be some tougher problems that act as a way to differentiate the competitors. This is clearly the hardest problem in this group. That's okay. The odds of you getting 100% are roughly 0. And that's okay. Don't worry about it.